We're just going to turn the page and fill out the first couple pages here today. So this first page is translations. And there's a lot here for you already. So it says, let's read this together. A translation slides all points of a figure the same distance in the same direction. If you're like me, I like to highlight my notes when it's all printed for me. And then a vector is what tells us how to move a figure in a translation. So a vector is a quantity that has both direction and length. That should just say direction and length. So notice we don't have like an x and a y axis here. It's just an arrow, and the fancy word for that is a vector. So it has both direction and length. So this vector is telling us to move 5 to the right and 3 up. And we can write that in what's called component form, 5, comma, 3. So it's a little bit like a point, right? Like if it was the point 5, 3, we would move from the origin 5 to the right and 3 up. This is very similar. It's just we're not starting at the origin. We're starting at the end point of the vector, wherever that may be. And so it's worth noting that this first number here in any vector tells you to go left or right. So we'll be going right if it's positive, and we'll be going left if it's negative, just like a point. And then here, just like when we're graphing points, we'll go up if it's positive, and we'll go down if it's negative. Okay. All right, let's just jump into example 1. So example 1 says, draw the image of triangle ABC after a translation along vector V. And this symbol right here means vector. It's sort of if it was an arrow, then that would look like a ray, and the way that a vector is different is it has just the top part of the arrow. So vector V. So here's our vector, and I'm going to highlight it. This vector tells us how to move every single point, and we always need to start at the end point and move toward the arrow. And so I think it can be useful to sort of make a triangle so we can see exactly where we're moving. So we're moving 1, 2, 3, 4 to the right, 4 to the right, and then we're moving 2 up. So we're going to take points A, B, and C and move all of them exactly that way. So we're going to start with point A, and we're going to move 4 to the right and 2 up. 1, 2, 3, 4, 1, 2. Go ahead and do this along with me. And it's a good idea to label that A prime right away. And we'll take point B and we'll slide it 4 to the right, 2 up. B prime. Do the same with C, 4 to the right, 2 up. C prime. So this vector doesn't do anything, like we're not moving the vector. It's just there to show us how to move each point. And obviously once you have all 3 points, go ahead and connect them. And there's our image. So remember, we have the pre-image and the image. So pretty simple. Example 2. Draw the pre-image and image under, this doesn't make sense, under the translation along, that word shouldn't be there, along this vector. So this time the vector is not drawn for us. We have to know from this component form of the vector how to move it. So just like a point, this -4, this first number tells us left or right. And since it's negative, we're going to be going left. So I'm just going to write under this left 4. And then the 1, remember, like we wrote up here, it's positive, so that means we're going to be going up. So we're going to move each point left 4 and then up 1. So that's what that vector means. So the first step here is to draw the triangle with those coordinates. Label it ABC, that's your pre-image, and then take every single point, move it left 4, up 1, and put the little prime markings by it. So what I'd like you to do right now is pause the video, go ahead and finish this example, and then check back with me in a moment to see if you got it right. We're back. So hopefully this is what you got. A, B, C, and then A prime, B prime, C prime. Here's our pre-image and here's our image. And it's always a good idea to make sure a translation is a rigid transformation, meaning the size and shape are the same. So double check. If it doesn't look like they're the same shape and size, then you've made a mistake and you should check your work. All right, moving on. Example 3. This time the transformation is done for us, and it says specify the component form of the vector that maps triangle ABC to triangle A prime, B prime, C prime. So it's important to realize this is the old one and this is the new one. And I know this is the new one because the prime markings are there. And so it's wanting us to fill this information out, right? Like, what is the vector that got this to move here? So to do that, we're going to take this vector, here it is, and we're going to figure out what are the movements to get from the endpoint of the vector to the end of it. So I'll make a little triangle. Now we have to be careful. This is the first vector we've seen where it goes down, but keep in mind that this first position is for the left and right movement. So even though we might think we're going down and to the right, this first number has to be this value here. So we're moving to the right 1, 2, 3, 4, 5 units, 5 units to the right. That's positive, the positive direction, and so the number that goes there is 5. And then the second number is the up-down movement of the vector, and so we're going down 1, 2, 3, 4. Down is in the negative direction, and so we'll put -4 there, and that is the component form of the vector. All right, we have one more example here, and this one's a little different, but it's more like what we did last time we worked with transformations. It has this coordinate notation. So it says translate triangle ABC with A, B, and C according to the rule. So whenever I'm dealing with coordinate notation, I kind of like to write out my points A, B, and C along with the new points because for me that's a lot easier. We'll talk in a moment about how we would do it otherwise, but that's how I'm going to approach this problem. So let's start by drawing the pre-image. You go ahead and do that with me. And then where I have room, I'm going to have to do this up above where I've got some room. I'm going to write my points out again. So we've got 3, 0, 2, -2, and then 4, -2. And we're going to apply this rule to these numbers. So again, what this means, the first position of my new point, A prime, I'm going to take the x value and subtract 2. So my x value is 3. 3 minus 2 is 1. My y value, I'm going to take the y value from my original point and add 3. So the y value is 0. 0 plus 3 is 3. Take a moment. I'm going to have you finish this example on your own. I'd like you to fill out B prime and C prime, graph it, and then see if you can figure out what the vector was that got it to move. So take a couple minutes, do this example, and then press play again. So this is what I got. Hopefully you did too. If you didn't, you should have known you made a mistake because you would see that your triangle didn't look like it was the same size and shape as our pre-image. But this is what I got. So what I'd like for us to do now, even though the question didn't ask us to, is think about what's the vector that moved it. And to do that, we can draw in our own vector, and we can choose any of the points. I'm going to use B and B prime because they're kind of off on their own and it won't get as messy. So I'm going to draw the vector that moved B to B prime. Make sure that the end point is the pre-image point and the arrow is on the image point. So there's our vector. So that vector, if we write the component form, remember the first number is our left-right movement. This went left 2, -2. And then it went up 1, 2, 3. And so I want us to think about how this coordinate notation is similar to this vector. And I hope it's pretty obvious that basically this number came here and this number came here. So when you see the coordinate notation and you're dealing with a translation, it's actually not necessary to go through this now that you know about vectors. You can take any coordinate notation like this, draw the vector, and then just move each point according to the vector, left 2, up 3. That's a quicker way to do it. The rules for translations. So again, you can kind of see down here, the A came there, the B came there. We're going to try to generalize these rules. So if A is positive, then we're moving to the right. If A is negative, we're moving to the left. B is our up-down movement, so if B is positive, we're moving up, and if B is negative, we are moving down. And that's really all you need to know about translations. They're pretty simple. So if you guys will turn in your rigid transformation books now to the middle, it should look like this. It's the reflections page. So we're going to talk now about reflections. The definition of reflection is here for you. It says, a reflection across line L maps a point P to its image P prime. And then it says, note, P prime is the same distance perpendicularly to line L as P is. And that definition is a little bit confusing, so we'll come back to it maybe at the end. But for now, I think if you think about reflecting in a mirror, I think you probably know what a reflection is and what it does. So we're just going to jump into some examples. So example 1 here says, draw the image of triangle ABC reflected across the y-axis. So the first thing I'd like you to do is highlight the y-axis because it's going to be much easier for us to visualize this if we are clear about where we're reflecting. So there's our line of reflection. And we can do this using coordinate notation. We can also do this by just mirroring across that line. So I'll show you what I mean. We're going to take point A, which is negative 5, 1. Let's go ahead and fill that in. Negative 5, 1. And we're going to reflect it across this line. So we're going to travel from point A to our line of reflection and in a perpendicular way. So we want to make sure that we're moving in a way that hits that at a 90-degree angle. And since we're working on a graph, these are all 90-degree angles, so that's pretty easy. And we're going to count how many spaces we travel, and then we're going to count that same number of spaces to locate A prime. So here we go. We're going to count 1, 2, 3, 4, 5. We hit our line of reflection. We're going to go 5 again. 1, 2, 3, 4, 5. That's where A prime will go. A prime. Let's do B prime. Here's point B. It's at negative 1, 1, so we can fill that out. And we're going to travel from B to our line of reflection. We're going to hit it at a 90-degree angle, and then we're going to count the same number on the other side of the line. So we count 1 to our line, we count 1 on the other side of it, and that'll be B prime. So notice that these points are the same distance away from the line of reflection. Let's do C. C is at negative 4, 4. And we're going to reflect that across the y-axis. So we'll travel to the line and count as we go. 1, 2, 3, 4. Let's count 4 again. 1, 2, 3, 4 on the other side. And that is C prime. Once you have your image points, this is our pre-image. Once you have your image points, go ahead and connect them with a straight edge to make your image. And there we go. I think sometimes it's nice to just remind ourselves this is the pre-image here, and this is the image here. And you can see that, like if I were to fold that up along the line, the two triangles would match perfectly. Let's go ahead and fill out our image points now that we have them. So A prime is at 5, 1. B prime is 1, 1. And C prime is at 4, 4. And so I wonder now if you can develop your own rule and coordinate notation for what happens when we reflect across the y-axis. And looking here, like I can see the x's and the y's are staying where they are, right? We have 5, 1, 4, 5, 1, 4. So the x's are staying in the x position, and the y's, 1, 1, 4, are staying in the y position, 1, 1, 4. But something happened to all of the x's, right? They were all negative at first, and they became positive. So something changed with the x's. So the x's stayed in their position, so we can put the x back in the x position, but they all became positive. And so we're going to put a negative in front, and that might seem a little bit confusing. So it's like, wait, they all became positive. But remember that that negative just means opposite of, right? So they were negative, we made them positive, and keep in mind that a negative is a positive, right? So we did the opposite of x, and then our y's stayed the same. And since our y's stayed the same, I'm just going to put a y there, and that's the rule. And this is actually the rule for any figure if you reflect it across the y-axis. The x's will switch to the opposite of whatever they were, and the y's will just stay put. So that'll always be our rule for reflecting across the y-axis. Let's do example 2. This time we're going to reflect across the x-axis. So I'm going to highlight the x-axis. This time it's our horizontal axis right there. And this time I was given 3 points, so I'm going to go ahead and graph them. I have M, N, and P, and I'd like you to go ahead, graph them as well, and label your points. This is our pre-image. So you have a little bitty triangle there. And this time we're going to reflect that across the x-axis. And the process is exactly the same. We're going to take our original points, we're going to travel straight down to our line of reflection, counting as we go, and then we're going to count the same number on the other side. So M, I'll count 1, 2, and then 1, 2, and that's where M prime will go. I'd like for you all to go ahead and finish this, locate your image points, and connect them to create your triangle. You don't need to pause the video, I'll do it too, but I want you to do it on your own without looking, and then you can check back in to make sure you did it right. So there's our reflection, and what I'd like you to do now, hopefully you got something that looked like this. It looks reflected. It also looks like a translation, right? The reason I know it's a reflection is because of where these points are located. If this had been N prime and this had been M prime, then it would have been a translation. But because the M's are each 2 units away from the line of reflection and the N's are each 4 units away, I know that this was a flip, a reflection. So take a minute and fill out your image points and then see if you can develop the rule on your own. I'll do it as you guys are working. So the easiest thing to see here is that my x's didn't change at all, right? 1, 1, 3, 1, 1, 3. Nothing changed about them, and when that happens, that means you can just plop it down. X did not change. My y's did change though, so let's look and see what happened here. My 2 became -2, my 4 became -4, my 3 became -3. So the value, the number itself stayed the same, but they're all opposite of what they originally were. And so as a reminder, that means we're going to put the negative sign, and that really just means the opposite of y. And this will be our rule whenever we're reflecting across the x-axis. And it makes sense, right? Because if we're reflecting across the x-axis, then if our original point was up a certain number, the new point will be down that same certain number. So the y value will just flip to the opposite side of the x-axis. Let's take a look at these shortcuts. So we've got 4 shortcuts, and you don't need to memorize these. They'll be given to you like on a sheet anytime you have a test or a quiz. But at least the top 2, you should be able to memorize because they're just kind of intuitive. If we're reflecting across the x-axis, and again, I'm going to highlight that, and I recommend you do it too because it's a little hard to see. If we're reflecting across the x-axis, my x values are not going to change, but the y values are going to become opposite of what they originally were. So x negative y. If we're reflecting across the y-axis, this time it's the x's that flop, right? Because if it was 2 to the right of the y-axis, my new point will be 2 to the left. So they'll be opposite of whatever they originally were. But the y values will not change. So those are the shortcut rules for reflecting across the axes. You'll also see a lot of problems here where you're reflecting across a different type of line. So in this problem, we're reflecting across that line, and the equation of that line is y equals x. This is not a rule. That is the equation of a line. That's the equation of this line here, okay? So it's not a rule, it's just the equation of that line. And if we reflect across that, you can see here we made a butterfly shape. You can almost tell just by looking at these points, like A is 2, 1, and A prime is 1, 2. And you can check with another one, like D is 1, 2, 3, 4, 5, 6, 2. D prime is 2, 6. So when you reflect across this line, something kind of funny happens. Nothing becomes opposite, right? If one of the coordinates is positive, it's going to remain positive, but they're going to swap places. So the x in our original point actually goes into the y spot in our new point. And the y spot in our old point flops into the x spot. So all you have to do if you're reflecting across that line is take those 2 numbers and just flip-flop them. You don't make anything positive or negative, you just flip-flop them, that's all. And then if we look at this last one that you'll see a lot, this is reflecting across this line here. We can do kind of a similar thing. A is 2, 1, and A prime is negative 1, negative 2. So I wonder if you can make an inference about what's happening here. I'm going to give you a minute to see if you can figure it out. So what's happening here is just like in this problem, they're flip-flopping, right? The 2 went into the second spot and the 1 went into the first spot. So they're going to flip. The y and the x trade spots. But they also both become the opposite of what they originally are. So I'm going to be careful not to say they're becoming negative. They're becoming opposite of what they are. So I want to write a couple of little hints in here because sometimes the coordinate notation is really complicated even when the rule is not. So let's try to write little shortcuts for ourselves. When we reflect across the x-axis, you just make the y value the opposite. That's all you're doing. You're making the y value the opposite. Everything else stays the same. When you reflect across the y-axis, you make the x value opposite. And everything else stays the same. When you reflect across the line y equals x, you're actually switching spots. So I'm just going to write a little note to myself. Your switch spots is what we're doing. And then when we're reflecting across this line, which has the equation y equals negative x, we're switching spots and making both numbers opposite. So if the original point was positive, the new one will be negative, and vice versa. So that's sort of writing out those rules using words instead of coordinate notation, because sometimes that's just easier. And then let's do example 3. Example 3 says, it gives us 4 points to plot, and then tells us to reflect across the line y equals x. So let's first plot those points. So you can do that at the same time I do. Okay, I've got a lovely little trapezoid there. And I'm reflecting that across the line y equals x. So I'm going to draw that line in. This line has a slope of 1, if you remember back to algebra, and a y-intercept of 0. So it's going to go start at 0, and it's going to go up 1 over 1, up 1 over 1. So it's going kind of along here. That's the line y equals x. And I think it's really helpful to draw that in so we can see what's happening here. We're going to flip over that line, but don't try to do it by hand. Use the rule. So let's go look at our rule for reflecting across this line. The rule says xy goes to yx, or in English, we're just switching spots. So what I'm going to do is come down here and I'm going to use coordinate notation to make sure I stay organized. So D was 2, 0. D prime, I'm just going to switch the spots. It's going to become 0, 2. E was 2, 2. I'm going to switch the spots, and that's a little funky because they're the same. So if I switch them, it's not actually going to look any different, and we'll see what that looks like on the graph in a minute. You guys go ahead and finish with F and G. And when you're done, go ahead and look up here. Obviously, if you need to pause the video, go for it. So this is what I got as my image points, and let's go ahead and graph them. So D prime is at 0, 2, so over 0, up 2, that's D prime. E prime is at 2, 2. It's in the same spot, so I'm just going to have to kind of write E prime next to it, but the same point. And the reason that it doesn't move is because it's actually on the line of reflection, so it's not going to move. F is at 5, 2. Oh, sorry, F prime is at 2, 5. And G prime is at 1, 5. And then we can connect our points and just double check, make sure that this looks like a rigid transformation. In other words, does the shape look like it's the same shape and size? And it does. So this is my image here, which is the original one. Oops, I said that wrong. That's our pre-image. And this is our image, which is the new one. Okay, that's it for today.